Okay, we're going to be looking at how to find out some information from these graphs and evaluate a function. Now, one thing you need to remember is you probably talked about in Math 1 that y was equal to f of x. And if y is equal to f of x, what that lets me know is the number inside this parenthesis is pretty much the x value. And then the number over the number that I get, the output, is the y value. So the input of a function is the x value on a graph. The output of the function, what it equals, is the y value. So here's how we do this. We're going to go over to our graph, and I'm going to go to where x equals 0 right here. And then I'm going to go from there, and I'm going to go either up or down to hit my graph. In this case, going down lets me hit the graph. And the point I get on the graph is right here. And that point has a y value of negative 1, 2, 3, 4, 5. So the answer there is that this one is equal to negative 5. We'll go ahead and work through a few more of these examples to help you understand. On this next one, once again, the number inside the parenthesis is the x. So I have an x value of 1. And then I'm going to mark it on my graph. So there's where x is 1, about right there. I'm going to go either up or down to my graph. Now, in this case, I have a choice. If I go up, I land on an open circle. If I go down, I land on a closed circle. Remember, an open circle is like an open manhole cover. You cannot stand there. It's a point that does not actually exist on the graph. So I'm actually going to need to go down. And then this one would also have a value of negative 5. We'll go ahead and try the next one. Give me a different color here. Let's see. This one, I have a negative 5. So I'm going to have 1, 2, 3, 4, 5 is my x value here. I clearly need to go up to the graph, and that gives me a y value of 2. So the number in the parenthesis is the x value of this point on the graph. So I'm looking for a point on the graph with an x value of negative 5 and then telling what its y value is. As I continue doing these, they're all pretty much going to work like this. Another one worth mentioning maybe is down here at g equals negative 2. So when I look at that one for g is negative 2, I'm going to have a negative 2 here as my x value. My y value is going to be, in this case, I'm going to have to go down. And then that one would be equal to negative 5 as well. Very common answer. Another one we might try is this one here, with the f is 3. When I have f is 3, got a different shade of green going on, I go for an x value of 3. This time I go up. Now, I've had some students say, Mr. Hess, that's not a point on the graph. Well, anything that's not an open circle counts as part of your graph. So anything that's not an open circle counts as a part of your graph. You'll go up, and you'll get this one as a value of 3. And the last one that's a little weird, this one here, f is 6. So if I have f equals 6, I go over here to where I have an x value of 6, and I notice if I try to go up, I don't hit the graph. If I try to go down, I don't hit the graph. So with an x value of 6, there's no place to hit the graph. So this is actually undefined. And you can abbreviate that UND, or you can write out undefined. But do not call this no solution. No solution is actually a different thing. This is undefined, meaning it actually does not have a point on the graph at all. So there is no graph for an x value of 6, so the function is not defined. I hope this helps you get the idea of how to use a graph to graph some of these, and we'll do another video on how to use Desmos.